Hi class, and welcome to another video lesson. On this one we're on 7.8 day 2. So we've already talked about inverse functions and inverse relations. Now we're going to dive a little bit more in depth with working with these. The first thing we're going to do is we're going to see if two functions are indeed inverses of each other. So what we did yesterday was we graphed both of these and saw that they were reflections over the line y equals x. Another way we could see if they are functions of each other is to do f of g of x, so put one function into the other, and do g of f of x, so put f into the g function, and if their identity equals x, then we know that they are inverses of each other. So when I say identity, like we have the additive identity, 3 minus 3 equals 0, a positive 3 and a negative 3, the additive identity is 0. We have the multiplicative identity, 3 times 1/3 equals 1. So the multiplicative identity is this number 1. Now we're just talking about the inverse identity, which equals x. So that's kind of some information that maybe you don't necessarily have to know for our next test, but here's the stuff that you do need to know for our next test. We have to do f of g of x and g of f of x and see if they equal x. That's how we determine whether these two functions are indeed inverses of each other. So we have the function f of x equals 3x minus 6. We also have the function g of x equals 4/3 x plus 8. The first thing we're going to do is we're going to do f of g of x. So g, we're going to put u into the f function. So f of g of x equals f of x, which is 3/4 x, which now it's not going to be x anymore. We're putting g into it. So times 4/3 x plus 8, and then we still have this minus 6. So now we are going to simplify. First, we're going to distribute this 3/4. 3/4 times 4/3 is 12/12, and 12/12 is simply 1x. Now we're going to distribute the second one. 3/4 times 8 is 24/4, and 24/4 is the same thing as 6. So we have x plus 6 when we distribute, and then we still have this negative 6 out here. So what do we get when we have f of g of x? We get x. And class, if they're inverses of each other, that's what we need. They equal x. But we can't stop here. We also have to do g of f of x. Because f of g of x could equal an x, but g of f of x may not. So we have to test both cases. So now we're going to do the opposite order. This one, f goes into g, so this function is going to go into here. So now, g of f of x equals 4/3 times x, which x is now 3/4 x minus 6. Then we're going to add 8. So just like we did the last one, let's first distribute. 4/3 times 3/4 is once again 12/12, and 12/12 is 1x. And 4/3 times a negative 6 is a negative 24/3, and a negative 24 divided by 3 is a negative 8. So a negative 8 plus 8, there we have it. Once again, class, we get x. So g of f of x equals x. So to answer our question from back up top, determine whether these two functions are inverses of each other, you can just write yes, they are inverses of each other. Certainly, I need to see your work. If you just guess on a test, I understand that you have a 50-50% chance of getting it right, but I need to see that f of g of x equals x and g of f of x equals x. Yes, they are inverses. Let's try another one. Determine whether these two are inverses of each other. Well, if they are, f of g of x is going to equal x, and g of f of x is going to equal x. So let's put g into f. F of g of x equals This goes into the f function. 3 times 3x minus 4 plus 4. Simplifying, 9x minus 12 plus 4. For f of g of x, we end up getting 9x minus 8. Does this equal x? Absolutely not. You can stop right here. You don't even need to do g of f of x because they both have to equal x. But if f of g does not, then absolutely not. They are not inverses. So if 1 equals x, if f of g of x equals x, then you have to do this one. But if f of g of x equals anything other than x, you don't even have to try the other one because they're certainly not inverses of each other. So that's one way to tell if they are inverses of each other. Another way is by graphing it. So now class, we'll call this blue line f of x. Okay? So here's what f of x is. Let's pick some ordered pairs. We really only need 2, but to be safe, I would recommend that we pick 3 ordered pairs. One ordered pair is left, 1, 2, 3, 4, 5, down 2. Left 5, down 2. Let's pick another ordered pair. 1, 2, 3, 4, 0. Another one is at -4, 0. And we'll pick one more. We'll go left 1, 2, 3, and up 2. Left 3, up 2. So if the red is the inverse, then its relation is going to switch its ordered pairs. So let's see if that works. If this is the inverse function of x, then the inverse function should have a -2, -5. It should have 0, -4. And it should have 2, -3. Here's all I did, class, is I just switched each and every one of these ordered pairs. Because that's what an inverse does. It switches the x and y. Let's see if all 3 of these points are found on our red line. -2, -5. 1, 2, 3, 4, 5. There it is. It's on our graph. Next one, 0, -4. That one's on our graph as well. It's looking good. And we have 2, -3. Yes, this is enough information to tell us they are inverses of each other. Yes would be the correct answer for this one. So all you have to do here now, class, for the next 2 is find some ordered pairs, see if both the blue and the red go through the ordered pairs and the inverses of those. So let's try this one. Are the 2 graphs inverses of each other? Let's first do the blue one. Let's call it f of x. Let's name some points that it goes through. We'll pick this one. We'll pick this one. And we'll pick, this one. We'll spread it out a little bit. So our first one is at right 2, up 5. 2, 5. Our next one is at right 1, up 3. And the third one is at left 2, down 3. -2, -3. If the blue and the red are inverses of each other, here is what the inverse of x should have. It should have 5, 2 by switching the order. It should have 3, 1 by switching the order. And it should have -3, -2. Let's find out. Does our red line contain the point 5, 2? Right, 1, 2, 3, 4, 5, up 2. Uh-oh. It doesn't look like it does. Right 3, up 1. Another no. Left 3, down 2. Nope. That red line does not contain the inverse of this. So that means the red and the blue are not inverses of each other. Are they inverses? The answer is no. Let's try the final one of this type. Are the 2 graphs inverses of each other? When it's a parabola, class, it becomes a little bit more difficult. However, it is done very similar. We're still going to pick several points. One point that you should be sure to pick on a parabola is always pick the vertex. So this blue one goes through 0, 0. That's its vertex. Now I would pick 2 points, one to the right of the vertex and one to the left of the vertex. So it looks like this parabola goes through that point on the right and goes through that point on the left. So those 2 points are right 1 up 4 and left 1 up 4. If the red parabola is indeed the inverse, we know that it will have the opposite of those points, or the reverse of those points. So the inverse function of x should have 0, 0 when I switch around the x and y, 4, 1, and 4, negative 1. Let's see if they do have those points. 0, 0, looks like that's the vertex. Right 4 up 1, that point is on there. Right 4 down 1, that point is on there. These are inverses of each other. So you can write yes. And obviously another way of checking if they're inverses is just sketch the line y equals x and just kind of see with your eyes, yep, it looks like they're inverses of each other. This one, if you can kind of see with your eyes, yep, it looks like they're inverses of each other. However, that doesn't work in every case, because if you would have drawn the line y equals x here, they might look like they are inverses of each other because they are very close. But as you can see when we did these ordered pairs, they weren't quite inverses of each other. So you can't always rely on this y equals x rule, because our eyes can sometimes play tricks on us. So make sure that you go through this work of getting f of x and the inverse function of x, switching around their ordered pairs and plotting them on the graph.